Good morning, Professor Moussas.
Good morning.
Do you hear me clearly?
Very well, yes.
Great, that's great. I would like to welcome you all in the Bibliotheca Alexandrina. I'm very glad that Professor Moussas is with us today. We have the pleasure of having him with us and that he agreed to participate in the cultural program of the Alexandria Project. So thank you for being with us today, Professor Moussas. Of course, we have achieved this by the great help of my professor, Dr. Magda Nouami, whom I really am deeply thankful for her always and endless support and help. Thank you, Dr. Magda, for all your help and support. Professor Moussas is a professor of physics, director of the Astrophysics Laboratory, and director of the Observatory in University of Athens. He is a co-author of many books, and he has written many articles in journals and during conferences participations. He has also participated in several science activities. Professor Moussas has won several awards, such as Hipparchus Award in 2010. Today, Professor Moussas will explain to us the Antikythera mechanism, which we can call metaphorically the oldest computer. Thank you again.
Good morning. Thank you very much, all of you, Professor Nouami, first of all, and naturally your students, and Rania, Sarah, Dina, Randa. Good morning, ladies and gentlemen. I am extremely honored to be with you today for this lecture, in which I hope I will present to you the history of, and prehistory also, of Greek astronomy mainly. And of course, this very old computer that we call the Antikythera mechanism. Although the name of this mechanism, as we will see, originally was tablet. So it is really the oldest tablet that we know. The work I'm presenting here is, of course, a work that I have done with very many people, including scientists, scholars, academics, archaeologists, that we have done at the University of Athens, but also at the National Archaeological Museum in Athens, and other universities like the University of Thessaloniki in Macedonia, Greece, and also the University of Wales at Cardiff of the United Kingdom. And of course, I thank all these people that have contributed to this study, or to the studies that I'm going to present to you. Of course, we are just across the sea, not that far from Alexandria. It's just, even by rowing, a few 2 or 3 days of journey, and people even in antiquity were capable of doing this journey very easily, till very recently. And communication between the two civilizations is continuous. In fact, in ancient Greek books, I have searched, and the term Egypt or Egyptian appears many more times than the term Greek appears in this Greek text. So this really shows the importance of Egyptian civilization and Egyptians to the Greeks, which continue even more today for very many reasons in present-day world. And Crete is really the entrance to Greece, Europe passed from Crete, according to Greek mythology. And it isn't really a myth, because all the civilization, really as we know it, passed from there as well, from Egypt, of course, first of all. And recently, with two colleagues, Dr. Tsikridis and Mr. Tsikridis, we have discovered something very new, the existence of time models, of calendars in prehistoric Aegean, going probably back to the 4th or even 5th millennium BC, certainly during the 3rd millennium, that's for sure. And of course, this comes from the fact that humans have been observing the time for very, very long. There was a time when there was no TV, I say to the students in the first year. They cannot not really believe it or consider that it's really like this, ladies and gentlemen. And at that time, even today, of course, we have the opportunity to observe the revolution of the sky, to see the stars, how they revolve around the Earth, also the planets, the moon and the sun, and also to count the time it takes for an event to take place, or the moon, for example, or the year, or the periodicity of a planet, of planet Venus, or planet Mars, Jupiter, and all the 5 then known planets to humans that we can see without the aid of modern day techniques like telescopes and space techniques as well. And even eclipses, they count eclipses for very long, and they realize that these phenomena are periodic. They repeat themselves in cycles of time, of course. And this type of events we have discovered in terracotta, in vessels made of clay, like this one we see on the screen, which date from the 5th millennium BC to the 3rd millennium BCE, in fact. And we realize that these patterns that appear time and time on these terracotta represent periods of time. So we have so many days, or so many months, or so many weeks. And if you count the months, the years, or the days, you have periodicities of the planets, and the sun as well, and the moon. And they know quite well the periodicities of all these 5 planets that we see now on the screen, that revolve, of course, around the sun, as we know very well. And they knew already at that time that they reappear in the same place every so many days, or so many months, or so many years. They count all that. And if we have, let's say, the example of Venus, Venus has a very long periodicity around the sun, is a bit less than 600 days, and it has it is divided in several phases, this period of Venus around the sun. And one very important periodicity is the month period that it takes to go from here is the Earth, this is the Sun, this is planet Venus that goes around like this, and from this point to go all around to become invisible behind the Sun, it takes 9 months. And it is for this, I believe, that humans associated women with this planet due to the periodicity of pregnancy. And because it has other very remarkable periodicities, this planet, it is very useful to have it as a mean to measure the time, because Venus goes 5 times around the Sun like this in 8 years. And this is equivalent to 99 months. So it is very easy to have a period of 8 years, which is equal to 5 periods of Venus and 99 periods of the Moon. And all over the world, the Greeks and other civilizations have used this periodicity. This is the so-called Mayan calendar as well, of which you have heard very many things, of course, within the last years. But we have realized that this appears already in the 5th millennium BC in some of these ancient terracotta. Oh, sorry. And we learn from ancient authors, Plato, for example, that the first gods that the Greeks had, called Theoi, are the planets. So they were very important for humans, for the Greeks, at least. And they count the time it takes for Venus to go around, and they have this written in these terracotta. Here, for example, we have 8 years, we believe, and 5 periods of Venus. And this appears time and time again. Here again, we have 8 of these spirals, helices in Greek, and helix in Greek has the same root as the Sun, and also the same root as the time, the age. And we have 5 periods of Venus. And again here, 8 periods of the Sun and 584 days of the period of Venus, as we said before. And this 8 ray star appears in very ancient items like coins, and this is a Macedonian coin, for example, of Antigonus Gonatas, in fact. And we again see this period of 8 years, I believe. And again, this is from a Greek island, and time again, we have the same periodicities, several times, and also of other planets, like Mars. All the 5 known planets at that time appear in several of them. And a bit later, around 1500 BC, we have a very special item. In fact, it is a moon. This is a piece of stone. This is 8.5 centimeters in diameter. And it was found in a foundry in a metallurgical workshop where people could create many of these, pouring liquid copper in this mold. And people, Dr. Tsikirtsis and his colleagues, have studied, and they proved that you can use this as a calendar to know when the new moon comes, when you have the new year, the beginning of the year, and also when you have eclipses. Here we have it at a larger image. And this was a portable astronomical device that was, of course, a bit expensive for someone to have a device made of copper, and it seems that there was a market for it. So people around 1500 BC could use an expensive computer, we could say, or an expensive item, an astronomical instrument, or perhaps even astrological, but mainly to keep a calendar and also possibly to go around the globe, the Mediterranean, and everywhere. And calendars help people to develop better and better astronomy. Because to have an accurate calendar, you can start by observing, of course, the sunrise and sunset during the year. That changes the position of the sunrise and sunset over the year from one month to the other, from day to day even. And you can keep, as it happens in Egypt, in various remarkable big buildings like temples. In Greece too we have the same, and this is a place in Knossos, Crete, where you can keep a calendar from the sun, taking into account the sunrise from these doors of the throne room of the king of that time of Knossos in his palace. And again, a similar one, again from the same place, and many more in fact, all around Greece and all around the world. And we even have observers. There have been many of these small statues, usually found at the top of some mountains that we believe were observatories. Observatories where people like him or her observe the sunrise or sunset. And they know that if the sun rises from the top of that mountain, it is the beginning of the year. And we have these all over Greece, from Macedonia to Crete and all the islands, of course, time and time again. And these are around the 8th century BCE. So these are the ancient astronomers that we see here. And later, more or less 50 or 100 years later, we have some sort of spherical astrolabuses. This is what I believe was a small, portable, spherical astrolabe. And in fact, you can see the sign of stars on it. Again, here you see. You have a few meridians, an equator, and always an axis, the axis of the cosmos. And here again, this is the axis and several meridians, and these are the stars. And observing for centuries the sun and the celestial phenomena and the moon and nature in general, of course, they conclude that there are what we today call laws of physics. And in a very ancient Greek poem, we read that there are celestial laws that put the stars in their position and motion. And this really with just 3 words. Very poetic and very accurate. And that's how humans understand that we have causality, determinism. So we have laws of physics that are expressed accurately with mathematics, as Pythagoras said, for example. And we know, of course, that Pythagoras studied in Egypt for long, and all reputable Greek philosophers and scientists have spent a great part of their life in Egypt, studying, exchanging ideas, which is very, very important. And here we come to what I call idea diversity. To have many different ideas. Diversity is the process that permits the development of many different ideas in a region, in a country, in a planet. And this is extremely important, I believe, for humanity, for civilization. If you have many ideas, then you can select some of them that are good, or the ones that you believe that are good. And then you have the development of civilization, a better civilization that people had before these ideas, and of course, hopefully in the future we will have a much better one if we select the good ideas today. This is what I call idea diversity. And for the Greeks, it was very important to visit other places. Homer, for example, says that Ulysses is a very important and wise person because he has visited many countries and he understands the mentality of many nations. So, he's much better educated than others. And it really is like this, that if you have the opportunity, the possibility to have various ideas in a country or in many countries, this eventually permits to have the survival of the better ones. And so we have what we call progress. And as, for example, in Greece, due to the great diversity of the soil, many mountains, many islands, we have frequently a desert environment, let's say near the sea. And if you go up the mountain just 20 kilometers away, you have an alpine environment. And that's why you have many varieties of plants. In the same way, if you have many small city-states, as they were in Greece, then you can have small places where people can gather and exchange their ideas, as in a village, for example, or in a city-state, in a parliament. And this leads to the idea diversity. we have, for example, here, a very ancient parliament, probably 4th or even 5th millennium BC, from one small Greek island. And there are many around. This one is from Crete, and this is from Athens, the most famous of that. And it is very interesting. Well, here is the podium. This is the place of the forum that all ancient important people were addressed to the Athenians. And right here, to the right, just behind this man, we have the oldest known observatory in Greece. A real observatory with instruments, I mean. And in these places, we have what we call agora. Agora means a place where you can express yourself, where you have the possibility to talk. And in fact, right here is also the altar of Jupiter that protects the people that express themselves. So he is the god that protects the people that express their views. Very important to have this god Jupiter right here. So it is the agora where people start developing the ability to talk and to express themselves. And at later times, when Alexander comes, we have greater ideodiversity because of the fact that this great kingdom, the empire, permits people to communicate and exchange ideas. That's how we have the development of science and philosophy at his time. In fact, he was a very good pupil of Aristotle, as you know, so he was very well educated, and he continuously had books with him in his, and scientists as well, and philosophers as advisors, all the time that he went around the globe, and of course in Egypt, where we have him becoming an Egyptian, accepting the civilization, your civilization at least, and becoming really local. Ideas go with him, and science and philosophy becomes much better and engulfs much more people. And that's how eventually we have this ancient computer. These are the three largest parts of it. Imagine that the diameter of this one is only 13 centimeters. So in a reconstruction, and I can show you now one that I have in hands. And this is really the reconstruction made by Mr. Kriaris. So this is like a clock. It has two faces. Here you can see. It has many dials, and it shows all the phenomena any astronomer or any educated person would like to have. For example, we have pointers for the sun and the moon. There is the moon, for example, and the sun is here. And all around we have the year, and in fact this year is with Egyptian months, because the educated Greeks, the astronomers, under the influence of Alexandria, adopt the Egyptian calendar. The names of the months are the Egyptian months. Of course, they are written in Greek, because they are meant for the Greeks. And also we have the zodiac, a map of the sky, and as the moon moves around the earth, it changes phases as well. So here we have this part of the method, while on the other face of the mechanism, we have right here at the top we have the 8-year calendar that we have discovered in the ancient terracotta. This is the period of Olympic Games and the other important for the Greeks games at that time. So it writes, we read here Olympic, Pythian, Nemean, Isthmian. These are the various very important for the Greeks and also at later times even for the Romans festivities that we have here. And all around here we have another calendar that lasts 19 months, years, and it is a calendar based on the phases of the moon. We Greeks use it today for various Christian festivities. It's exactly the same calendar. Of course, this one is BC, but we still use the same one today. And down here, we have another calendar that gives predictions of the eclipses of the sun and the moon, both. It even gives their hours, hour, day, month, year. This is the prediction. So it is really this instrument a very important astronomical device, a computer. And it is a computer that works with gears. Gears that one moves the other, and they really move the world. So it is the first planetarium. It is the first known mechanical cosmos, the first mechanical universe. It really works the same way that the electricity meter that you have at home works with. And even more important, this instrument is really the epitome, the best example of Greek philosophy. Now, you wonder perhaps, how can we say that an instrument made of gears, bronze, copper with tin, has anything to do with philosophy? But it really is like this, ladies and gentlemen, because one to, first of all, conceive that can create a mechanical universe, a mechanical cosmos, a clockwork mechanism that gives the position of the sun, the moon, the eclipses, probably the planets. I'm sure that it had the planets as well. You need to understand the philosophy of that time, mainly what today we call Pythagorean or Pythagorean philosophy, that the cosmos, the universe, nature, can only be described with numbers. Now, when Pythagoras says nature is numbers, he really means that we can understand nature not only by our eyes and ears and senses and brain and mind, but using mathematics that represent the laws of nature. And the laws of nature enables us, the humans, to predict astronomical phenomena. For example, in this ancient terracotta that we saw before, humans can predict how long it will take for Venus to go from the farthest point to the closest point to the Sun, to move from one place to the other. 9 months, for example. And several millennia later, we have this mechanism that, as we said, it was called tablet at the time, Antikythera in Greek, which is really the epitome of Greek philosophy, of the philosophy of pre-Socratic philosophers, mainly of the Pythagoreans. Very important one. To build it, you have to have accepted that we have causality, laws of physics that are described only with mathematics. Very, very important. And then you can, oh, by the way, just to remind you that a few years back, we had an exhibition at the planetarium of this mechanism, and I mean in the library, and this is the panel that we had of the exhibition at that time. Here is a cross-section of the mechanism. Here we can see the gears, is from a painting, but it represents very well reality of the mechanism, and it has been found in a shipwreck that sank sometime between 80 to 60 BC. And the functions of the mechanism are various. It is an astronomical instrument that enables you to even make measurements, to measure how far is this star from that star, for example, the moon from that star, or which is the altitude of the sun at noon or any time during the day. And if you have appropriate tables, then you can use it to calculate your latitude and even your longitude. So it is an astronomical computer. It is what we call an anaphoric clock. It is also a meteorological instrument because it predicts the various changes of weather, when to expect to have rain in October, for example, in Greece, when to do various agricultural activities, extremely important too. A mechanical universe, a planetarium, as we said, a calendar mechanism, various calendars, based on the sun and the moon, based on the phases of the moon, and also based on the eclipses, both of the moon and the sun, of the two. And very useful for people, very useful for a ruler to know when you have important festivities, like the Olympic Games, the Pythian Games, the Nenia, the Isthmia, the Na, etc. And these were not only athletic, they were games of competitions of poetry, drama, theater, and music, and dance. So all this together at the same time. And it was also a time for peace. Wars had to stop, and humans had to leave their arms before going to the Olympic Games. My father's village, for example, is the place where they used to leave their arms before going to the Olympic Games. And they had to stay for a quarantine, eating all the same things to make sure that they have not used drugs to have better performance, that is for the athletes. No. Well, humans have always been the same, of course, in Greece and everywhere, all the globe. And, of course, it is a teaching device, and also a device that the rich person can have it at home to show up to the friends. But it is also very useful for the measurement of geographic latitude and longitude too, which is very difficult, but to a good accuracy, I believe. So you can use it to create maps for cartography and also for navigation to travel around, at sea or land. It is all that. And it gives, as we said, the position of the sun and the moon, the eclipses, the planets, using, and now this is new, the period of Saros. Saros in Greek means something that sweeps. So it really covers all the sky, the moon as it goes around, well, not really like the sky, it goes like sweeping the near the ecliptic and repeats the eclipses every 18 years almost, or even better, every 54 years in 1 month, which is very important for the prediction of eclipses. While another period of 19 years and 76 years has to do with the repetition of the phases of the moon. The moon will come back to the same position where it is tonight, let's say at 10 o'clock, with the phase that it has tonight, near this star after exactly 19 years. And another very important thing is that this instrument, as all scientific instruments, has a manual, a user's manual. A user's manual that tells us how to open it, how to set it up, how to orient it towards east part of it, to make observation, how to measure a distance in the sky. And it has many references to the planets, the motion of the planets. A very important term is the term cosmos, where universe. Here it says, of the cosmos lies. And another place, little golden sphere, probably the sun pointer. And sun ray, pre-perforated holes stationary points of the motion of the planets, and many other terms. And here we have the laws of physics that they have used to predict here, for example, and this is an Egyptian symbol for the year. It says 76 years, 19 years. It is the period of Meton, the repetition of the phases of the moon. And down here, 223 months, the repetition of eclipses. A viewfinder, we read, sun ray, to measure the altitude of the sun probably. And let's put another question. How can we construct such a mechanism? What we need really? Of course we need astronomical knowledge, mathematics, the notion of causality, laws of physics, and the notion of modeling, that we can translate the mathematics, the circles, let's say, or the periodicities to years, because we can perform mathematical operations using years. So these are very important to construct such an instrument. Of course, we need appropriate technology, because you can construct things based on the technology that you have. It's very important to have the appropriate tools and skills, of course. Again, very important. So, to have astronomy, you need observatories. And this is the observatory of Meton, that I mentioned before, where he discovered this 19-year period. Probably he refined it in calculation, because I think that this 19-year period was known to prehistoric people as well. Of course, you need clocks, various types, and instruments like the mechanism that were clocks as well. This is a huge clock, it's 12 meters high. It is an octagonal tower with sort of clepsydra that also moves a mechanical instrument similar to the Antikythera mechanism that was inside. And these days we studied it with one of my students. That's how you have the mechanism. But by the way, this one has been constructed around 100 BC, at the beginning of the 1st century BC. And that's how you have the mechanism, which was an instrument constructed probably between 150 to 100 BC. This is the most probable. And here you have a section of the mechanism with the various gears. Here is the moon and the sun. You have the year all around, which is the Egyptian calendar, as we said. And a very important part is these 4 gears that I have called Kepler's gears, because they give the motion of the moon with a variable speed around the sun. Around the earth. So the moon moves with a variable speed, faster when it is close to the earth, slower when it is far, and then again faster and slower and so on. With a very ingenious device here, the constructor, sometime between 150 and 100 BC, constructs this part of the mechanism with a coaxial. Please notice this one. This is coaxial. Gives the variable speed of the moon. This is really incredible. And the dials. Here we have the dials of the eclipses and of the phases of the moon. An 18-year calendar and a 54-year calendar here, while at this place we have the 19 and 76-year calendars based on the phases of the moon. So here we have really a synopsis of what I have already told you about the mechanism. What it shows, the position of the sun and the moon, the phase of the moon, the new month when it begins, and also several other astronomical phenomena. And to summarize, it is an important astronomical instrument that enables the people, the user, to have whatever one wants to know concerning the time. When we have the beginning of the month, when we have the beginning of the year, when we have festivities. What was the name? As I said before, the name was tablet, which is very surprising. And also at times it is called sphere, and also astrolabe, or little astrolabe. Also meteoroscopion, which means to observe the sky, or to know the meteorological phenomena. It's similar. And in this ancient text, which is the story of Alexander, we have his mother, Olympia, talking to Nephthero, that was the king of Egypt at the time, and this pharaoh takes off his pocket a tablet made of gold and ivory, with the 7 stars, with a clock, the sun and the moon. The sun is made of crystal, the moon is made of diamond, because diamond at that time it means a hard rock. And the so-called Jupiter is bluish, aquamarina perhaps. Saturn is made of serpentine, Venus of sapphire, Mercury of emerald, and the clock is made of marble. And this royal tablet that human mind cannot understand, made of ivory, ebony, gold, and silver, with 3 concentric circles, with the 36 stars, the zodiac, the sun in the middle, and the moon. And another very interesting here, again, a table one can construct that shows continuously the motion of the sun. So it is really a clock. Sun moves, so you have the hour as well. And, well, this is similar to the one before. You can take with this instrument the position of the apogee and perigee of the sun and the moon and the planets at the appropriate region of the sky, at the appropriate degree in the sky, it says. So, ladies and gentlemen, this instrument that is made of gears of brass that rotate around axis and has indicators is the oldest computer that I wanted to describe to you today, and all the bits and bytes of your computer, of your telephone even, they have exactly their roots in this very ancient instrument that has also very deep roots in Alexandria and Egypt and Greece. And here, ladies and gentlemen, I am ready for discussion, for questions, with great pleasure. Again, I thank you very much for the invitation. I'm very honored to be in the library with you today, even electronically. And I hope that soon I will be there in person, perhaps for another talk or talks. Thank you very much. Thank you very much, Professor Ioanni. Thank you very much, all of you, ladies and gentlemen.
Thank you very much, Professor Moussas. Thank you very much for your very informative presentation and for sharing with us your great knowledge.